Hello, everyone, and welcome back where we've been tackling just FRQs, trying to get ready for the AP exam. We've learned everything. We learned it all. So we're just doing FRQs, and particularly we're looking at FRQs dealing with arrays, array lists, classes, methods, those type of things, because this year it's a little bit slimmed down. So we're looking at 2013 question number 2. This is going to be very similar to Mancala, but kind of watered down so that you could basically complete it in an FRQ timed format. So it says a multiplayer game called Token Pass has the following rules. Each player begins with a random number. Let me go ahead and boot up my IntelliJ while I'm talking about this. Each player begins with a random number of tokens. It's at least 1, but no more than 10. You should be thinking math.random that are placed on a linear game board. You should be thinking an array. There is 1 position on the game board for each player, so each slot on the array is a player. After the game board has been filled, a player is randomly chosen to begin the game. Each position on the board is numbered, starting with 0. The following rules apply for a player's turn. The tokens are collected and removed from the game board at that player's position. We're going to pick up all of the seeds. The collected tokens are distributed one at a time to each player, beginning with the next player in order of increasing position. So we'll go down the array, distributing those seeds. If there are still tokens to distribute after the player at the highest position gets a token, the next token will be distributed to the player at position 0. What we're saying is once we would go out of bounds, we instead wrap around to the beginning, and then we'll drop it at position 0. The distribution of tokens continues until there are no more tokens to distribute. The Token Pass game board is represented by an array of integers. The indices of the array represent the player positions on the game board, and the corresponding values represent the number of tokens each player has. The following example illustrates one player's turn. So we're playing a 4-player game, meaning that our array has a length of 4. The player at position 2 was randomly chosen to go first, and that is indicated with this arrow. Also, we see a number of tokens in each slot. That was randomly decided. This person randomly got 3 tokens. This person randomly got 2. That number is going to be between 1 and 10 inclusive. Okay, so we're going to pick up these 6 tokens, and we're going to proceed to go this way, increasing, dropping 1 token at a time. We're going to take these 6, so this would be a 0, and then we drop 1 here. And because that is the last position, we would go out of bounds if we tried to increase any more. We're going to wrap around to the beginning, drop 1 here, 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 wrap around again to here. It's all around on these 6, right? So we're going to pick up 6. We're going to go 1, 2, 3, 4, 5, 6. That is kind of written out here, but we see the ending state as a result. Right? Player 2 got to go. We picked up the 6 seeds and we sowed them. The Token Pass game is represented by the Token Pass class. They give us the instance variables, right? And we need to write the constructor in part A, and then we're going to essentially write the move method in part B. Let's get started. How's everyone doing today? I'm going to create a new project. This is under 2013 still. This is number 2. Question number 2 from 2013. Okay, I'm going to expand my project folder, right click on the SRC, make a new Java class. We're calling this one Token Pass. I'm going to do it as one word. I believe that's how they did it. Yep. Token Pass. We got, I'll just copy and paste everything, I guess. It's the easiest way to go about this. That's arguable. So we got these 2 instance variables. We are then going to see our constructor. Right, I know it's a constructor. It doesn't have a return type. Name matches the class header. And we will format this a little bit better in just a moment. Okay, I kind of like that guy being down here. So let's go ahead and get started on our constructor. I'm going to flip back to the document to see if there's anything special we need to read. I think I got it figured out. Write the constructor for the token pass class. The parameter player count is being passed in as an argument. Represents the number of players in the game. Recall that also dictates how big our board will be, represented by an array. The constructor should create the board array to contain player count elements and fill the array with random numbers between 1 and 10 inclusive. The constructor should also initialize the instance variable current player to a random number between 0 and player count minus 1 inclusive. So creates blah, 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 blah. Let's get started. First thing we want to do is create this board. Right? Before I can start filling it with random elements, I need to create it. Now, in theory, we could go ahead and assign current player first. It's just not a big deal. So I'm going to take this instance variable and I'm going to assign it to a new integer array using player count as a parameter. Right? This tells me how many players are going to be in the game, and I'm going to use that as my length of my integer array. That's it. We're going to create that. It'll have player count, number of elements, but they're all zeros. They tell us we should then assign random values from 1 and 10 inclusive. So our goal is to then loop through this board and then save in a random number at each position. So because I'm going to be saving elements back into the array, I need an index. What that means is we should probably use a for loop and not a for each loop. So I'm going to use IntelliJ's for I shortcut. Right? We'll start at index 0 as long as I is less than, you could say player count. You could also say board.length. Those are the exact same. But with each iteration, I want to change the current element in our board. I'm going to set it to some type of random value. So we're going to use math.random here. Now, you can use the random class that I taught a lot of my students in CSP. You're not forced to use math.random here, but that's what we've kind of used most recently, so I'm going to stick with that. If I just tried to do math.random, this is going to give me an error because this is producing a double. This is producing a double in the range of 0 up to 1. Right? I guess a better way to represent that to show that it's a double is that we're getting a number 0.0 inclusive up to 1. What that means is that you're getting a number that looks like 0. Blah, blah, blah. Okay, that's not very useful. And the way that we end up modifying it is that we want to like multiply and add that sort of thing to get what we want. So the first thing I would say is let's tackle the multiplication. When you multiply, what you're effectively saying is number of possibilities. How many numbers are in 1 to 10 inclusive? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 possibilities. Okay, so I'm going to multiply it by 10. Again, this is still mad at me currently because this is still a double, but by us multiplying it by 10, we effectively shift over a decimal. So instead of getting like 0.98, I get 9.8, blah, 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 blah. Okay, that's still a double. If we were to cast it as an integer, right, notice my syntax is now happy. In theory, I am going to take this number, force it to be an integer, which is going to force truncation, which will get rid of this fractional part. In theory, it's producing 9. I said in theory, right? Because due to precedence, this cast is actually happening before multiplication. Casting has a pretty high precedence level. So what's happening currently, and the reason why IntelliJ is giving me an issue, this is actually saying it, it's not an issue, it's not a syntax issue, it's kind of a, are you sure you want to do that? If we were to cast this, we're going to get 0 every single time, because keep in mind, that original number was 0.98, well, whatever. Okay, so if I were to take this number and then cast it, well, I'm going to chop off the fractional part, I would end up with 0. So what we want to do is force precedence. We want this math to happen first. By using parentheses, I'm going to have math.random produce a number. We multiply it by 10. That'll give us something like 9.8. Then the cast will get applied. Okay, here's the thing. This is number of possibilities. 0 is still in that range. And as it turns out, 9 is actually going to be my highest. We then, once we get the number of possibilities, this number range is going to be 0 up to 10. This is the current number range. We see that 0 is a possibility when we don't want it to be. And we see that 10 is not actually a possibility, right? This is exclusive, even though we want it to be. So what we're then going to do is then shift that range. And you can shift by just simply adding. And that's it. So this will now give us the numbers 1 to 10 inclusive. And it's actually going to be casted as an integer, so that is our actual number range. Sweet. So we go through every position in our board, saving in a random number 1 to 10. So we replace all those zeros. The last thing we want to do is figure out who should go first by setting the current player. And we're going to set current player to, again, some type of random. Now, the number of players I have is player count. So that tells me what I should multiply by. Again, this is going to be a double, so I want to cast it as an int. Again, casting has a higher precedence. So I want to force precedence by saying, let's do the multiplication first. This is going to random me a number between 0 and player count, inclusive, exclusive, right? Or the way it's phrased here is player count minus 1 inclusive. And there we go. This is our constructor. We create a new array. We go through, we fill it with random numbers, and then we randomly decide who should go. That's it for part A. Let's look at part B. Write the distribute current player tokens method. The tokens are collected and removed from the game board at the current player's position. These tokens are distributed one at a time to each player, beginning with the next higher position, until there are no more tokens to distribute. Okay. Let's take a look at this. There's some post-condition stuff I'm interested in, which is most importantly, what happens to the current player, especially once they finish their turn. So it distributes the tokens from the current player's position one at a time to each player in the game. Distribution begins with the next position and continues till all tokens have been distributed. If there are still tokens to distribute, when the player at the highest position is reached, the next token will be distributed to the player at position 0. Precondition. The current player has at least 1 token, so we don't have to worry about that. Postcondition. The current player has not changed. So it tells us in our postcondition here, we don't have to worry about advancing the current player. Okay. First thing I want to do is figure out how many tokens. I want to basically pick up the tokens out of that position, all right, and hold them in our hand. So I'm going to create this variable, number of tokens. And what it is all of the tokens that are in the current player's slot. Keep in mind the current player is already predetermined coming in here, right? So we're just going to pull that value from our board at the current player's location. Okay, if we're looking back at our example, right, current player is 2. That's what this value is. Whereas board at to the current player will give me 6. That is the value of tokens. Let's leave it as a comment to know that our number of tokens is 6 based on our example, right? We could maybe even, using our example, decide that current player is 2. So I've picked up my tokens. Here's part of the problem. Right now I have duplicate tokens. I have 6 tokens in my hand, but there's still 6 tokens at this position. So what I want to do to represent them fully being picked up coming from the board and in my hand is take that exact same position and set it to nothing. Right? We're picking up the tokens. They're in our hand. This is representing our hand, and that slot is now 0. Now we're ready to start distributing them. Right? I want to loop through. We don't want our current player to change. So I'm going to, right? We don't want the current player to change. So I'm going to create some type of variable that represents my current index. Where am I at on the board? In theory, I could use current player and just keep increasing it and modifying current player, but our post condition clearly states that we don't want to do that. So let's create our index, which is I, and it is simply the current player. Now, as long as I have tokens to distribute, while we still got tokens, we're going to keep going. First thing I want to do is modify my I. I want to go up 1. Right? We're going in increase in order. So let's just do an I++. So I'm now at the next index. Right? If we're following our example, I's value, right? Here, I's value would be 6. First thing I do is I++, sorry, not 6, 2. First thing I do is an I++, which puts me at index 3. Looking at our example, we're here. I then want to drop a token at this position. Right? The way that we're going to simulate that is that we take board at I. Right? That's the position I want to modify. It is going to be what it currently is plus 1. You could express that as board at I becomes what it currently is plus 1. But this could actually just be simplified as board at I plus plus. And I'll leave this guy as a comment. So we increase this one by 1. If we follow our example, this spot is now 11. Right? We're going to drop a token here. Now here's the thing. It came from our hand. And so we need to represent that as well. And the way I'm going to do that is by subtracting one of our tokens. This is the gist of it. Right? Our tokens would then go to 5. It came from our hand, it goes into the board, and we're going to keep doing this until we run out of tokens. Now, if we look at the very next iteration, right, I have these values coming in. We would ask, is tokens greater than 0? Yeah, there's 5 of them. Okay, we do an I++. Okay, we're now at index 4. Board at index 4 plus plus. If we look at our example, there is no index 4. Right? So I need to wrap around. Now, you could put an if statement check in here. If we're out of bounds, put me back at index 0. And you do that before you try to drop a token in. If we're out of bounds, the way I know I'm out of bounds is that I is greater than or equal to the length of my board. If we're out of bounds, let's just reset I to 0, back to the beginning. Right? Let's take a look at this example. We just increased I to 4, which means we're here. We would ask, are we out of bounds? Well, yeah, we are. Okay. I becomes 0. That puts us right here. We do all that right before we drop a seed in. Cool. Now, you can do this. And I expect a lot of students nationwide to take this approach. The big brain thing is to use modulus. We're going to update I each time. I is going to become what it currently is plus 1 modded by the board length. Say what? Okay, coming into this, I was 3. I'm going to do 3 plus 1. Let's write out this formula. 3 plus 1 mod 4. Right? Our current value for I is 3 coming into this iteration. We're going to add 1 to it, and we're going to mod it by the board length. The length of my board is the total number of players, which is 4. So what I end up with is 4 mod 4. Keep in mind modulus is getting the remainder, right? So 4 mod 4, 4 goes into 4 one time with nothing left over. So that produces a value of 0, and that is what I'm saving into I, meaning that we are wrapping back around to index 0. Then we're going to place a seed there. It was 3, it's now 4. We're going to subtract 1 from our tokens, we're left with 4. And then we would continue to repeat. Let's do one more iteration to see how this formula still works. We would ask, is tokens greater than 0? Yeah, I've got 4. We're going to take I, add 1, mod it by our board length, which is 4. Okay, well 0 plus 1 is just 1. 1 mod 4 is actually going to give me 1. We would ask, how many times does 4 go into 1? Well, no times. What do you have left over? 1. So that's what we're saving back into I. I'm going to change the element at board 1 by increasing it by 1. That'll go to 3. I'll then subtract 1 from my tokens, and we got 3 left there. Sweet. Let's try this. I'm going to right click on the SRC. Let's make a new Java class. This is going to be my driver where we plug in a main method. I'm going to create a token and pass object. And we are going to just model it after our example. And our example has 4 players. What I probably need to do is let's overload this constructor so that it doesn't do the random stuff. I want to be able to create this exact example, right? We'll test the random one, but I do want the exact example. So I'm going to overload this constructor by taking in an existing array, right? So we're going to do public token pass. We're going to take in an integer array that'll represent our board. And we'll also need to know who the current player is. Okay, I can derive information like player count from this because it'll have the number of players based on the length. And the current player is just something we're going to pass in to set. What this is going to do is say that this .board, our instance variable, is going to be equal to the parameter being passed in. We're going to save this parameter into our instance variable. And then we're just going to set our current player to the current player. Okay, back in my driver, let's create an integer array that looks like this guy right here. I'm going to create an integer array. Doesn't matter what we call it. And I'm going to use an initializer list here. We got 3, 2, 6, 10. So this is setting the length as well as the values. We'll create token pass, but we're going to pass in board, and our player is actually going to be 2. This should give us this exact scenario. Okay, in order to see this, right, I'm going to try to print off token pass. And we're going to basically just get a bunch of gibberish. That's because we didn't write a toString, and so we need to do that. Okay, I'm back in token pass. I'm going to include a toString so I can see what my board actually looks like. And all this is going to do, really, is print off the contents of the array. Now, I could use a loop, but there's a utility class that exists that already has a toString for us. So all I really want to do is see what the board looks like. So I'm going to call the arrays utility class, which has a bunch of static methods, to actually produce a toString for our board. Okay, I hovered over that, hit Alt-Enter, so it would import. Keep in mind, on an AP exam, A, you wouldn't need to do this, but B, we also wouldn't need to import, and that is because you just assume everything is imported. Now when we take a look at our token pass, we see that this array makes up its board. We should also maybe check to see who the current player is. So I'll tack on current player. And this will be important so that whenever we do some of our other methods, we don't want current player to actually change. Okay. Sweet. So we have the initial state. We got this state. What we want to do is call our method that should pick up these 6 and drop them correctly. I'm back in my driver. I'll take our token pass game and we're going to do distribute current player tokens. I then want to see the effects of that. This is the board with current player 2 as the game begins. We're going to pick up these 6 and then drop them in. We should end up with 5, 3, 1, 12 with current player still being 2. That's it. Let's chill.